Hi all, this is Priyadharshini working as an assistant professor in the Department of Artificial Intelligence and Data Science. Today we are going to look into the next topic called database sharding. So we all know what is sharding. So sharding, it is nothing but a method for distributing a single data set across multiple databases, which can then be stored on multiple machines. So this allows for larger data sets to be split into smaller chunks and stored in multiple data nodes, increasing the total storage capacity of the system. So this is called sharding. So it is a form, sharding is nothing but, when you consider, it is a form of scaling known as horizontal scaling, or you can also even say it is scale out. So as additional nodes are brought on to share the load. Horizontal scaling allows for nearly limitless application scalability to handle big data and even for intense workloads. In contrast, when you use vertical scaling, it refers to the increasing power of a single machine or a single node server through a more powerful CPU, increased RAM, or increased storage capacity. So do you really need database sharding? Yes, database sharding, as with any distributed architecture, it does not come for free. So there is overhead and complexity in setting up shards, maintaining the data on each shard, and properly routing requests across these shards. Before you begin sharding, you have to consider any alternative solutions to work for you. So you can also see vertical scaling or specialized services or databases replication. So all this you can see. So we'll see what are advantages. So it has increased read-write throughput when you shard. Storage capacity also increases. It is highly available. So when we consider the disadvantages, let's see what are the disadvantages. So sharding, as I told you, sharding, it is a database architecture pattern related to horizontal partitioning or horizontal scaling. It also divides the large data set into a multiple services or the shards. Each shard is an independent database, and collectively they would constitute a logical one. It is a type of horizontal partitioning that splits large database into smaller components which are faster, easier to manage. So when we talk about shard, it is an individual partition that exists on separate database servers to spread load. Data sharding is needed when a data set is too big to be stored in a single database. So why sharding? As both the database size and number of transactions increase, so does the response time for querying the database. So the costs associated with maintaining a huge database can also be the skyrocket due to the number and quality of computers we need to manage the workload. So data shards, on the other hand, have fewer hardware and software requirements and can be managed on less expensive service, that is your commodity hardwares. So before seeing into the architectures, we'll see what are the disadvantages. So disadvantages include the query overhead, as I told you previously, complexity of administration, and the increased infrastructure cost. Let's see what is sharding architecture. So in sharding architecture, we have three kinds. One is key-based, range-based, and directory-based. So key-based sharding. Key-based sharding, it is also known as hash-based sharding, which involves a value taken from newly written data such as customer ID, a client application, or a zip code, and plugging it into a hash function to determine which shard the data should go to. A hash function is a function that takes input a piece of data and outputs a discrete value known as hash value. So look into the example as how the shards are typically it is sharded. So remember, if you shard, the row-wise information will be sharded in a particular database. Range-based. So range-based sharding involves sharding data based on range of a given value. So the main benefit of this range-based sharding is that it is relatively very simple to implement. Every shard holds a different set of data, but they all have an identical schema as one another, as well as the original database. The last type of sharding is the directory-based sharding. To implement directory-based sharding, one must create and maintain a lookup table that uses shard key to keep track of which shard holds which data. So this is also a major disadvantage of having the lookup table. The correct information should be stored in the lookup table. So the main appeal of directory based sharding is its flexibility. So range based sharding architecture limits you to specify range of values, while key based limits you to fix a fixed hash function. So it is very difficult to change later on when a hash function is used on a particular key value. So on the other hand, directory based sharding allows us to use whatever system or algorithm we want to assign data entries to shards, and it is very relatively easy to dynamically add shards using this